Hello, and welcome to the next episode in my Blender tutorial series. In this episode, we're going to be modeling an I-beam. In doing so, you'll see me use many of the skills we developed in the previous episode, and I'll talk at a higher level about how to come up with the design process in the first place. However, and possibly more importantly, I'm going to be going into detail about how to make materials for everything that you model. Right now, we've got brass and rubber, and these are fine, but galvanized steel is different. And by the time we've made this, you'll be able to make a wide variety of materials on your own. This is an enormous topic though, just like modeling. The way I'm going to approach this is to essentially teach you what you need to know and really explore this sort of thing if this is what speaks to you. In the last episode, we learned a couple of edit mode tools, in particular how to make loop cuts, how to select rings, how to use the inset and extrude tool, and most importantly, how to find out more information on many of the tools used in Blender. If you'd like to support me making this content, please consider joining my Patreon, link in the description below. Let's get started. To begin with, let me just set up a new collection so we can get to modeling. And here we are, a blank slate. This is what we're going to try to create. Looking at this, one of the questions you are inevitably faced with is where to start. There's probably several approaches you can think of. The one I'm going to go with is I'm going to try to create the center of the spine here, and then I'm going to extrude out the wings, and that'll give me this I-beam shape. Because of that, my mental picture starts with a cube, so let's go ahead and make one. For the moment, I'm going to come out of the camera view so I can see this from a perspective. The first step we want to do is to scale this, but I want to take this opportunity to show you a little quirk of how tools are used in Blender. I'm going to put my mouse right here and hit the S key to scale. And what you're going to notice is it is very sensitive. Very small movements of the mouse make the thing basically go wild. Now, what if I start the mouse over here and press the S key? Now I have to move the mouse a lot more in order to get this thing to move. What's the difference? The simple answer is that Blender figures out where the origin of this object is and where your mouse is, and when you press S, it creates a line between them. Whatever that distance is represents making no change whatsoever. Doubling that distance means doubling the size of the cube. Having that distance means having the size of the cube. The smaller that distance is to begin with, the less you have to move to double it, which means it's just that much more sensitive. If I start out here, now doubling it means moving outside here, and this is a much bigger distance. The immediate takeaway from this is that you always want to keep track of not only where your mouse is, but where the origin of the object is when you start using any of these tools. You may wonder why Blender did this. The ethos, as I can tell, that the Blender team uses is they want to take a tool and make it as versatile as possible. One of the things they do very often is ask the question, where is the mouse pointer? At its most basic, Blender asks which pane is the mouse in. So if I press A, you'll notice it selects the camera and the cube, basically everything that's visible. However, if I put it over the outliner and I press A, now it's going to select everything in this outliner, including things that are invisible. On the other hand, on a much smaller scale, if I'm here and I press S, it's asking where's the mouse in relation to the origin. This mindset means you have to be especially careful about where your mouse is. Usually, this is just fine. It does have some amusing implications for some other panes though, and I'm going to take this moment to describe for a second. If I go to the scripting tab here, this just lays out a bunch of panes so that I can type stuff in here. I can click on New to create a new file, and if I type in A, it'll type the letter A. But if I put my mouse over here and I press A, it's not typing anymore. If you're like me, when you put your mouse somewhere and you just let it go, sometimes the mouse goes over here and you start typing, and stuff starts going berserk. Just keep that in mind. Blender team, if you're listening, if I'm on a pane here, please give me some way of selecting this pane so that all of my keystrokes go here, regardless of where my mouse is. That would be very handy. Anyways, back to the tutorial. Alright, so let's model this I-beam. If I start making edits like scaling it here to make it thinner, I can do that, but I have to remember to apply the scale after, otherwise edit mode functions that rely on the scale, like bevel, will be operating with a scale value other than 1, and it might look weird. For the moment, I'm just going to do my edits inside of edit mode. So I'll hit Tab, grab these two planes, and scale them in on the X. Then I'll take this and this, scale it in on the Z-axis a little. Probably take this in a bit more. Now, to make the wings, I'll make two loop cuts. Then I'll scale these out in the Z-axis. So that way they go up like this. This doesn't have to be a perfect square, but it's probably good to get it close. Let me head into face mode. Grab these, 1, holding shift, click, 2, holding shift again, 3, and 4. Then I'm going to press E, and I'll press S for scale, and then X for X-axis, and I'll just bring these out like so. Something like that looks good to me. Now I'm not quite happy with the aspect ratio here, so I'll select this front face here, and this one, and this one. Turns out I don't want to hold shift to click all these things. and you can use what's called circle select. If I press C, you'll notice I have a circle here, and I can roll the mouse wheel to have this thing get bigger or smaller. Essentially, I am painting selection, so I can click and drag, and anything the circle touches becomes part of the selection. And thus we are all connected in the great circle of selection. Right, anyways, let me grab the ones on the back side here too. Press C for circle select, click and drag. If I end up selecting more than I need, the way you get rid of a selection is you use middle mouse click. You can right click when you're done, and that'll take you out of the tool. Okay, so let's scale this out. That looks about right. Let's go ahead and put it in the scene. Oh, that is way too big, so let me scale this down. Let me give it a rotation, and that'll be fine for right now. Let's go ahead and light this thing. I'll go into my lighting collection, add a new plane, and let me just tinker with this for a bit. Okay, so I've done a little bit of playing. In the end, what I ended up with was a plane that looks like this and one that looks like this. And that gives me some definition here, so I can see the eye portion of this. I would probably spend some time and get some more shadow here, but I do like the gradient here. I would like a little bit more definition along this edge, but again, this is sort of the playing with the lighting phase, and I'll do that in a bit. The main thrust of this episode is going to be talking about materials, so let's get into that. Give me a second to set up the workspace. This is a shader editing pane. You can get to it by clicking here. We've seen this before with other materials, so with that in mind, let's go ahead and add a material to this. We'll go ahead and select it, and I'll go to New. And as you can see, we have a shader. First, a little background that'll help contextualize what you're about to learn. This is a shader. A shader is a program that's written in one of the shader languages, and these nodes represent functions written in that code. One thing most shaders have in common is that they're best run on a GPU, a graphics processing unit, which is a specialized piece of hardware that's very good at quickly rendering pixels on the screen. It turns out that the computations needed to draw pixels are very repetitive, which is good because it needs to happen many times per second. Because of this need, it's been heavily optimized, and in doing so, they made a design model that introduces some limitations on how it can be used. The trade-off, though, is that it's very fast. All that means for us designers is that whenever you want to do something with a shader, you have to shape your approach to the problem to fit within that model. In this case, that just means learning how to use nodes. I'm painting with a pretty broad brush here, and I'm skipping a lot of details so as to make a good introductory video about shaders. For right now, we just want to focus on how Blender uses these nodes and how we can use it to get stuff on the screen. The first thing is that the inputs for these nodes are going to be on the left, and the output is going to be on the right. Data, air quotes, flows through the nodes from left to right. These sockets have data types. Normally in programming, you have different data types, things like strings or integers or floats or whatever, and truly these are no different. There's only a few that we need to deal with here though. Green indicates that this socket takes shader data. What that means is what's going through here is information about what's actually going to be put on the screen. These gray sockets are floats. They are single numbers, and that's why we have these sliders here, which represents that number. Yellow and purple sockets are almost the exact same kind of data. Inasmuch as they're collections of 3 or 4 float values, the difference is mostly contextual. Yellow sockets generally mean color, in the form of R, G, and B values. Sometimes there's an alpha value, whereas the purple sockets tend to be vector data, the X, Y, and Z location, or rotation, or scale, that sort of thing. Generally, because they're the same data types, you can plug the sockets into one another, and Blender will figure out how they should work. You can actually get some pretty cool effects that way. Let's talk a bit more about this principled BSDF. The general idea is that you give this thing physical parameters that help capture what this thing is, like its base color, how metallic it is, how rough the surface of it is, that sort of thing, and it's going to take that information and draw something on the screen. So for example, if I take this base color and I make it purple, we get bubblegum. Delicious. One thing to notice is that though this is a particular shade of pink, not every pixel here ended up that color of pink. As far as we, the designers, are concerned, that's because we put a light here. Blender has to do math to figure out how that light and this object interact. That's the work of the shader here. Now here's where things get interesting. We're going to feed data to this socket in order to have this color be different at different locations of this thing. To make this easier on ourselves, let's enable an add-on that comes packaged with Blender. If you click on Edit, go to Preferences, go to Add-ons, type Node Wrangler here, and check it here. Right now I have it checked because I don't ever have it turned off, but this is already installed with Blender and all you have to do is activate it. I don't know why they don't have it activated, but whatever, here we are. What the add-on does is it gives us a couple of shortcuts that'll make this process a lot easier. What I would like to do is to give this some kind of information. To do that, I'm going to use a generator. To bring up the list, we'll hit Shift-A, and I'm going to go down to Texture. You can see we have a whole bunch of textures here we could use. We're going to pick Voronoi. Let's just plug it in. This gives us something to work with. Essentially, the way you can think about this is that this is going to ask, hey, what should be on the surface? This thing calculates what color should that surface pixel be, and it's going to ask, what is this base color? Which means it's getting information from the Voronoi texture generator. And this thing is going to say, well, this one should be black, and this one should be pink, and this yellow, and this green, and every single color it gives will be dependent on whatever this function does. Then we take that base color, and this shader does stuff with the metallic and roughness and index of refraction and alpha and all that good stuff, and it actually shades the pixel from this base color to something that's in this 3D universe with the lights and everything. That is ultimately the purpose of a shader. You can plug other things into here, and at some point we probably will, but for right now, let's just roll with this. Interestingly, we can use the other outputs from the Voronoi texture node and use those to inform the base color of our principled BSDF, but how does that work? Well, Blender is capable of transitioning between various data types. Not all, but when it comes to turning a float into either a vector or a color, it can do that. It just says, okay, for all the RG&B values, use this one single number. That's why it shows up as gray. Whenever the RGB values are all the same, it's essentially a colorless gray thing. You can also put the position in here, and this actually looks really cool. I don't know why we get this rainbow. I'm sure if I sat here and thought about it, I would be able to figure it out. But for right now, let's just enjoy it for what it is. Now let's take another look at the galvanized steel picture. You can kind of see what I'm going for here, but we're going to have to change this from what it is right now to something that looks more like galvanized steel. To do that, we're going to use some more nodes. I'll start off by selecting the Voronoi texture, and I'm going to use a keystroke from Node Wrangler, Control-T. You'll notice what it does is it essentially sets up a texture coordinate node and a mapping node. Okay, look, I'm going to take a moment and complain. The input for this thing right here, this Voronoi texture, is very poorly named. It's called vector. This is more or less the same thing as declaring a variable in programming and calling it integer. This tells you nothing about what this thing does. Blender, please be better about this. For right now, all you need to know is that if you put in information for this vector here, it's going to distort this thing somehow. To show you, let me come out of this rendered view and go into the material view, just so it updates live. I'm also going to hide this for the moment just because it's in the way. At any rate, if I take this and I shift it, you'll notice it's moving in the X direction along its local axis. If I hit G and hit X twice, you can see its X direction goes that way. So if I change this, it moves along that axis. I can also rotate it on, say, the Z axis. Looks like it's rotating. And I can also scale it up or down along any axis I wish. Now, of course, what I would like is to have this thing scaled in so it looks more like this. But I don't want to have to do this for this particular object. The reason is that I want something that automatically understands what its scale is. Let's undo this. The thing that'll do it in this case is the object coordinates. Okay, now this gets a bit detailed. I'm going to take an aside to explain how these texture coordinates work, and to understand that, we're going to look at what's called UVs. Okay, we're in a different file. Don't worry about keeping up with this, just sit back and watch. All I'm doing here is explaining the concept of a UV map. Imagine you have a soda can like this, which as you can tell has been perfectly modeled and is absolutely a soda can, and there's no questions about that. How could you cast any aspersions about that? Anyhow, imagine you wanted to texture this thing. Well, how do you paint on it? How does that information get stored on the computer? I could, of course, put a giant picture right here, and then I have the question, how does this get put on the actual can? Well, if this was a real thing with paper and scissors, I would have to cut this up and then wrap the paper around the soda can here, maybe cut out like a top, put it on the top, maybe something for the bottom. Well, that's exactly what happens. If I select A, you can see I have all of the different faces here. Now, of course, this isn't real pen and paper media. I'm not cutting anything up with a pair of scissors. But as you can tell, I've essentially taken this picture and broken it up into pieces that I can put on the can. Then what I would do is I would take the piece of paper, draw on it, put whatever label I wanted here, and then put it on the can. This right here is what's called a UV map. It's called a UV map because U and V are the names of the axes of the texture coordinates, which is what this is showing here. And we have to use different letters so that we don't confuse them with the X, Y, and Z axis of the 3D world we're dealing with. The UV indicates we're dealing with a purely 2D world, which in context means texture coordinates. The best way to understand this is that there's a one-to-one mapping between verts over here in the 3D world and verts over here in the 2D texture world. And what this does is it maps between them. And it does so on a face-by-face basis. To see this, we can click through. This face matches up with this face, this one with this one, so on and so forth. There are a lot of different things to know about this process, but for right now, we just need a broad strokes understanding. To see this in action, I've changed things a little bit in the file. Again, don't worry about the details. What I want you to really pay attention to is the fact that I can go into texture paint mode, and now I can paint on this, and it'll show up here. If I turn the camera, I can paint like this, or I can come over to this pane, and I can click on Image Editor, go to Paint, and now I can paint over here too. And as you can see, we get something across the top here. So as you can see, we now have a perfect soda label. Soda. That's not ominous at all. Anyways, the point is that we're able to paint on these things with these UV textures, but this is a little different than what we're doing with the I-beam right now. The way we're representing galvanized steel is with something called procedural textures. That is, instead of using a pre-made image texture like this masterpiece, we're instead using something that generates a texture, in this case, the Voronoi texture. Nonetheless, we still need to know what these UVs are, because if we get this wrong, then our Voronoi texture will look very off. Back in our file, in the UV editing tab, our UV map looks like this. Now we could come in here and try to manually move these vertices so that this looks natural, and in many cases that's actually what we'll have to do. But for this one, it's simple enough that we don't have to worry too much about this. That is, we can rely on what's automatically generated by the sockets of the texture node without having to tinker too much with this underlying map. But having at least a surface level understanding like this of how UVs work will be incredibly beneficial to you as you go to make your own things, especially when you have to dig into it. What the texture coordinate node does is it essentially gives us access to the UV coordinates that Blender comes up with. Over time, we'll experiment with different output sockets. For right now, let's just pick object. Don't worry so much about what it does, just understand that it does what we need for right now. Let's go ahead and scale this so that it's not so small. Let me show you why. Let's head to rendered mode, turn the lights back on, and I'll hit F12. And what you'll notice is it looks a little bit like noise. If I zoom out, in fact, this could come across as just pure white. This is in fact how white is created for most monitors. It's a combination of red, green, and blue. We want to make these cells a little larger so they show up. To do that, we can change one of the inputs for this node, and that input is the scale. Note that the variable scale for the Voronoi texture node is different from the scale in the mapping node. You can kind of think of them as local variables in a function. So I'll bring this down. And that looks pretty good to me. Let's go ahead and render that and check. Yeah, that's good. I can see these cells a lot better. Okay, now it still looks like some kind of pastel rainbow candy. What do we do about that? Well, there's a couple of things we can do. Let me zoom out. I'm going to grab these, move them over. What we would like to do is to essentially change this to something that we can control, but that's in black and white. Galvanized steel is mostly gray, although if you look closely, there is some tint to it. Let's do that in order. We're going to make this gray, and then we'll add some tint. To make it gray, I'm just going to use a black and white node. And if you're not sure if a node exists or not, just search for it. So for example, I'll press Shift-A, I'll go to search, and I'm just going to type in BW. And hey look, RGB to black and white. Now I can drop this node right here, and you'll notice it's taking in a color and dropping out a value. That's exactly what we want. We now have black and white. Before we add the tint in, I want to change the metallic and roughness values of this so that it more closely resembles galvanized steel. To that end, what I really want you to understand is that you should play with these. In order to understand what the roughness and metallic do, we're going to change them and just see what happens. Let me drop the roughness down to 0. And you can see this looks more like a mirrored surface. You can see the reflection of the light in it. If you pan the camera around, you can see that reflection shift. If I increase the roughness all the way up, you can see this becomes very matte. What matte means in the art world is essentially the opposite of perfectly reflective. Light that falls on a matte surface is going to be scattered in all directions, whereas if it falls on a reflective surface, it'll scatter in a specific direction, meaning reflected images in its surface don't break up and you can still see details in them. Set this back to 0.5. Now let's mess with the metallic. If I bring this all the way up, you'll notice it gets darker and a lot more extreme in value. If I bring the roughness down now, it becomes virtually a perfect mirror. Galvanized steel is somewhat shiny, but this is a bit much. So let's just tune these values until we get something roughly like what we want. This is getting closer, but I don't like how this light is falling so evenly across all of these different cells. Indeed, these cells in the real world are actually zinc deposits. There's some really complicated process by which it's formed on the steel. I don't know much about it, but what I do know is that it reflects light a bit differently depending on what angle it's coming in at. So what we can do is we can play with this a bit. I might like to use this value to inform what these two things should be on a per cell basis. I'd like to use the different values I've got here, but in order to see what they are, I need to get rid of the shading. So what we're going to do is we're going to hit Control-Shift-Click. And what that's going to do is it's going to temporarily make this node be the thing that we're looking at. That is, temporarily, we're skipping the principled BSDF, which is the shader that puts all that shading on there, and we're seeing directly the grayscale values that come out of the black and white node. This is a very handy trick, and if you're going to be doing much with shaders, you'll be doing it a lot. So keep that keystroke in mind. One detail that can help unlock your understanding of this is to observe that the values in tone, going from black to white, really range from 0 to 1, and by looking at this, we can make an estimation as to what those values are. The darker it is, the closer to 0, and the lighter it is, the closer to 1. The fact that the values range from 0 to 1 will be useful in just a moment. What do we want the metallic value to be? We know we want it to be pretty high, so we probably don't want these dark values here. In order to change that, what I'm going to do is use what's called a color ramp. So I'll hit Shift-A, hit Search, Color Ramp, and I'm going to click this in here. Essentially what this is doing is it's saying I'm going to output a color, and you can see what the color is. In this case, it's the grayscale we're getting here, which, remember, is a value between 0 and 1, but the place it's getting that color from is from this gradient here, and what this value is informing is how far along this thing you should go. So for example, let me hit Control, click on this. Now what I'm going to do is I'm going to make this drastic. I'll make this red, bring this up, make it red, and I'll make this blue. Click this, click it out here, make it blue. Now watch this. Where this thing was very dark, it's near this side, and so it's red. And where it was very bright, it's blue near this side. We'll notice that it never quite gets to either really vivid blue or really vivid red, and that's because we didn't have a factor that went low or high enough. Let's understand what the color ramp does. This red value is at position 0. So if you feed this thing a factor of 0, it's going to output red. This is at position 1. If you feed this a value 1, it'll give you exactly blue. What you should notice is that we never really got to either 0 or 1. 0 would be black and 1 would be white, but this is more of a dark gray and a light gray. However, this allows us to fix that. We can change these sliders until we get the red we're looking for and the blue we're looking for. So I'll grab this and I'll slide it up. And I'll take the blue slider and drag it down. That means the brightest we're getting is out here, and the darkest we're getting is down here. Now, let's change these to the values we'd want. Thinking about what this metallic is, around 0.82 is about as metallic as we'd like to go. What we'll do, we're going to set this to be that. Take the saturation and bring it down, and 0.82 is around, I don't know. Here, that's close enough. Then, we do want this to be a bit less metallic in some places. I'm not exactly sure where, so let's just go ahead and eyeball it. Bring the saturation down, and bring this down to somewhere in here. This means that it's going to be very metallic here, and only mostly metallic here. Now all I have to do is to feed this in, so I'll bring this down, and I'll feed this to the metallic, and now we can take a look at what this does. I'm going to use the Node Wrangler shortcut, Control-Shift-Click, and you can see that it's a bit different. What I want you to sort of think of these color ramps as are mapping functions. That is, you make some kind of a texture that has values between 0 and 1, and you map those values to these colors here. The trick is to think about the 0 and 1 values coming from the textures as something that drives that function. The more you play with this, the more you'll get used to it. Once you have your head around that, you should be able to use these sorts of things in order to inform any of these nodes. And indeed, a lot of these noise textures essentially get used for exactly this purpose. So what we'll do is we'll duplicate this with Shift-D. I'll bring this value down here. That value again is between 0 and 1, and then we can bring this into our roughness. Now again, these colors being our output, that this thing is going to have a very high roughness at this value. This thing is outputting like 0.8, which means it's very rough and thus very matte. And this thing is outputting like 0.36. So we probably don't necessarily want this much roughness. I'm going to bring this down. There, I'm roughly happy with that. And if you're following along by doing this, you can of course tune these values to something you feel is more appropriate. But for right now, I'm happy with that. The next thing we'll do is we'll add in a tint. This is where we're going to take this value and play with it a bit. To add tint to this, there's actually a couple of ways of doing it. The first and most obvious one is to add another color ramp, put the factor in, send this color output to the input of the base color here, and then simply change the colors to whatever we want them to be. So I'll select this one, change its color here, we'll give it a little bit of a bluish gray tint, and then we'll do the same thing here. Perhaps give this one a lighter one. Honestly, this is good enough, but here's the thing. Right now I'm using blue to sort of give this a false color. Real galvanized steel isn't necessarily blue, so it may be that later on I decide that gold or orange or red or something like that would work better. It's not too hard to make that edit. I could come in here and select different colors. But what I would really like is to be able to tint this with one single color and have it give me a lighter and darker gradient without having to worry about the color ramp, wherein I have to set the color twice. Let's back up a step. So here's another key binding. I'm going to use Ctrl X. That will delete a node, but preserve the link between them. What I'm going to do instead is going to start by actually adding in a single color. Search for RGB. I'll give this the bluish tint I want. I'll move this over here. And now what I can do is I can actually combine these two together. Now there's a few ways of doing this. First, I could just manually add in the node. Search for mix color. Certainly this works, and I can plug everything in as I like. Or, if I would prefer, I can hit Ctrl, Shift, and right-click drag, and you'll see I get this green thing here, and then that will automatically plug this in here. And if I twirl this down, you'll see this is the mix color node we had before. As you can see, this black and white node is outputting to the mix color node, and then that's going through the color ramp, and that's not quite what we want. To fix that, I can simply drag over here and over here. And now we're fixed. Which method you like best to reroute the noodles will be up to you. I just wanted to show this to you because it is a really cool keybind that comes with Node Wrangler. So now what we're going to do is we're going to observe that we're mixing this blue color with the black and white output here. The output of this mix node, the result socket, is governed by a couple of things. The first is this factor. If I set the factor to 0, it outputs everything on the A channel, which in this case is our blue. If I set the factor to 1, it outputs only things from the B channel, which is our black and white node here. In the middle, it outputs a blend between them. How it blends them is given here. You have a bunch of different ways of blending things here, and if you have any experience with Photoshop, you'll recognize many of these. We'll leave it set to mix right now because this is largely giving me what I want. Now, if I want to change this to a gold color, say, I could move this down here and the whole thing updates. For the purposes of this demonstration though, we'll leave it at blue. The last piece I want to share is a bit of an advanced technique, but it's something that's very powerful and illustrates the flexibility you truly have here once you really understand the system. The edges of these patches here typically aren't straight and even like this. Normally they're a bit jaggy, so let's represent that. The way we're going to do that is through this mapping node here. This was the node that was automatically added when we pressed Ctrl T earlier with the Voronoi texture selected. As mentioned earlier, this lets us move, rotate, or scale the thing. What we're going to do is we're going to change this location not uniformly by saying all of the X values change like this. This location represents a nudge, and when we change it like this, we're applying that same nudge everywhere. Instead, what we want to do is give this thing an individualized nudge, one that's different at every single point. To do this, we're going to need another noise texture. Instead of using Voronoi noise, I'm going to use Perlin noise. In Blender, it's not called Perlin noise, but rather just a noise texture. I've actually done a very in-depth description of this on my main math channel. I'll leave a link in the description. What the video explains is the mathematical underpinnings of the Perlin noise algorithm. To use this, we don't need that deep mathematical understanding. Yeah, it helps, but we can do something even simpler. Let me hook this up with Ctrl-Shift-Click. And what you see are smooth patches of noise here. To make this work properly, we'll use another mapping node, so Ctrl-T. We'll set this to object as well, and this will give us noise that's more evenly distributed. Now this is all well and good, but we have 3 values here, X, Y, and Z, and this is currently only outputting a single value, the factor, which is effectively the grayscale you see here. What we can do is we can simply take this noodle and plug it in here. To do this trick, we're going to hold Control and click, and we can just drag it in like so. Now you can see that we're getting color noise as well. This means we have R, G, and B values, which will convert into X, Y, Z values. What I really want you to see is that this scale here allows me to make this thing smaller or larger just like before. The reason that matters is because I want these details to affect the edges of our cells. Let's go back and look at our cells. We'll Control-Shift-Click this. We can see that our cells are about this size, so we want the noise to be around that same size. So let's click on this again, move this over. With this clicked back in, we can tune this to make that edge look good. So let's go ahead and plug this into our location. And then once more look at this.
And what you can see is our edges get all crinkled up. This is good, but this is perhaps a little too crinkly for my tastes. What I might like to do is to scale this down. The problem is that this scale doesn't influence that type of scale. Rather, if I scale this, you can see I'm just getting a whole bunch more noise here. This is pretty close. The problem is that it's pushing too far, and I'm getting these weird effects. It does make it look kind of like camo, which is kind of neat. I hadn't seen that before. What I might like to do, though, is to have this thing push less far in each direction. That is, this is giving color values that go between 0 and 1, which means this is being pushed out pretty far. We can actually scale them down. To do this, we can add in a vector math node. Let's set this to multiply. We're going to multiply by 1. As before, I'll click and drag. 1. Then I'll take this color value, bring it in here, and now I'm multiplying this color value by 1. This node makes a new vector by taking both x values of the two vectors here and multiplying them together, the two y values and multiplying them together, and the two z values and multiplying them together. It's not doing a dot product or a cross product or anything like that. This is just multiplication straight across the board. I can now bring this up to that location. Now I can change these values and get different effects. I'd like to change them all as a single value, so what I'll do is I'll say add another node, value. We're going to take this float value and let Blender automatically convert it to a vector, where all three of these values are set to whatever this is. Right now it's being set to 0, but if I set it to 1, we get back to where it's too much. Now I can set this to something that's less, and you can see that now I just have a gentle wave between these patches on the galvanized steel. Now, is this going to show up on the final render? I don't think so, but this is a very good technique for you to have in your back pocket for something that will. Speaking of that final render, let's take a look. Now, the only thing that's wrong here is I would say the lighting is a bit off, so if you give me a second, I'm just going to tune that. And there you have it. I have changed the lighting to give the edges a bit more distinctness here, a bit more shadow in the middle here, and a nice pleasant gradient here. You can still see the patches of light and dark along the back of this, and overall I'm very happy with it. In this episode, we learned a great deal about how materials work. We learned the basics of shader nodes and how to hook them up so that we can get stuff done. We learned how to take one type of data, a float value, and turn it into a color. We learned how to take a node like the Voronoi texture and use its output to inform the metallic or roughness or various other properties of materials that we might want to work with. We learned very many node wrangler shortcuts. Pretty much every shortcut I mentioned in this video is one you really ought to devote to memory. It will save you a lot of time. But now that you have all of these nodes available to you, I highly suggest looking through them, reading the manual, and seeing what you can come up with so that you can create your own ideas. As I've mentioned in previous videos, I have a Discord, and there's a lot of people there who all collaboratively work together to try to create more stuff. So if that's something that interests you, please feel free to join and share what you've made. If you have any questions, leave them in the comments below. And if you'd like to support me in doing this, please consider joining my Patreon. Link is in the description below. But that's going to wrap it up for this video. So until next time, take care of yourself, be good to each other, and I'll see you in the next one.